All right, another problem. We're asked this time to find a line integral, and it looks like a pretty ugly one. There's some functions in here that I don't really know how to integrate, but we're going to use Green's theorem, and it's going to work out. Now we'll use Green's theorem in this case to take the line integral and to write it as a double integral, and the double integral will be over the curl of our vector field, right? So that is going to be the the x derivative of the y component minus the y derivative of the x component dA. And what's really nice in this case is that, as before, the derivatives are simplified. The function is simplified tremendously through these derivatives. The derivative of square root of y to the fourth plus 1 with respect to x is just 0. So a lot of the terms in this mess go away. The derivative of e to the sine x with respect to y is 0. So the derivative of 3y with respect to y is just 3. We end up with the double integral of 4, a constant. So the really horrible function that it looked like we were starting with turned into a really nice and easy function. Now we're supposed to do that double integral on the path that we were asked was the circle of radius 3, so we're going to do a double integral on the interior of that circle. So again, whenever we reach this point of doing a double integral, we want to stop and say x first, y first, or polar. And in this case, polar is the way to go. We'll go 0 to 2 pi, we'll go 0 to 3 of the function 4, and we have r dr d theta for converting to polar coordinates. That's integral from 0 to 2 pi. Let's see, r squared over 2, so we're going to have a 2r squared, 0 to 3 d theta. Let's see, 3 squared is 9 times 2 is 18. So 0 to 2 pi of 18 d theta, that's going to be 36 pi as the answer. This looks like a very hard integral to have to deal with, but through Green's theorem, we convert it into actually quite much easier double integral to deal with instead. So whenever we have a closed curve and we're asked to do a vector line integral, we might want to consider Green's theorem. Will it be easier to do it as a double integral instead of as a line integral?